FastText in natural language processing. AI intermediate level. Introduction. In natural language processing, converting words into numerical vectors is essential for machine learning models. Traditional word embedding methods such as bag of words, word2vec, glove, have limitations, especially when dealing with rare words, misspellings, unseen, out of vocabulary words. To solve these problems, FastText was introduced. FastText is a word embedding model developed by Facebook AI that represents words using subword information, character n-grams. This allows FastText to understand words even if they were never seen during training. What is FastText? FastText is a word embedding technique that represents each word as a combination of character-level subwords, n-grams. In simple terms, FastText equals word embeddings using parts of words. Subwords. Example concept. Word means subwords means vector representation. Example. Playing means PLA. Lay. AYI. Yin. Ing. Each of these subwords contributes to the final word vector. Why FastText is important. Traditional models treat each word as a separate unit. Example problem. Run does not equal running does not equal runner. Even though they are related, traditional models may not connect them well. FastText solves this by breaking words into smaller pieces. Example concept. Shared subwords means shared meaning. This allows the model to understand word morphology, handle rare words, generate vectors for unseen words. How FastText works. FastText extends the word2vec approach by adding subword information. Example workflow. Word. Down pointing arrow. Split into character n-grams. Down pointing arrow. Learn embeddings for each n-gram. Down pointing arrow. Combine them means final word vector. Example. Apple means app. PPL. PLE. The final vector for apple is built from these subword vectors. Character n-grams in FastText. The key idea behind FastText is character n-grams. An n-gram is a sequence of characters of length n. Example concept. N equals 3 trigrams. Example. Where means less than wh. We, her, air, re greater than. Special symbols. Less than and greater than. Represent the beginning and end of words. These n-grams help capture prefixes, suffixes, word structure, vector representation in FastText. FastText represents each word as a sum, or average, of its subword vectors. Example concept. Word vector equals sum of subword vectors. Example. Dog means vectors of do, og, dog. This makes FastText more flexible than models that assign one vector per word. Handling rare and unseen words. One of the biggest advantages of FastText is its ability to handle unknown words. Example problem. Unhappiness. Not seen during training. FastText can still generate a vector. Unhappiness means hap, ppi, ness. By combining known subwords, it produces a meaningful representation. FastText versus word2vec. Both models are similar but have a key difference. Word2vec. Word means single vector, treats words independently, struggles with rare words. FastText. Word means multiple subword vectors means combined vector. Uses character-level information. Handles rare and unseen words better. FastText versus glove. Glove. Global co-occurrence statistics means word vectors. FastText. Subword information means word vectors. So, glove focuses on global statistics. FastText focuses on word structure. FastText training workflow. The typical FastText workflow is large text corpus, down pointing arrow, Split words into n-grams. Down pointing arrow. Train embeddings for n-grams. Down pointing arrow. Combine subword vectors. Down pointing arrow. Generate word embeddings. These embeddings are then used in NLP models. Example Python code. FastText can be used using libraries such as Gensum. Example code. From Gensum, models import FastText. Sentences equals I love, I is powerful. Model equals FastText. Sentences. Vector underscore size equals 100. Window equals 5. Min underscore count equals 1. Vector equals model. WV. I. Print. Vector. This code trains a FastText model and retrieves the vector for the word AI. Real-world applications of FastText. FastText is widely used in NLP tasks. Text classification. Handles rare words better in classification tasks. Spell correction. Understands misspelled words using subword patterns. Search engines. Improves matching for similar or related words. Chatbots. Better understanding of user input variations. Multilingual NLP. Handles different languages and word forms effectively. Advantages of FastText. FastText offers several key advantages. Advantages include: handles rare and unseen words, captures word morphology, prefixes, suffixes, better performance on small datasets, robust to spelling variations, improves generalization. Example concept. Subword learning means better word understanding. Challenges of FastText. FastText also has some limitations. Challenges include: larger model size due to subword storage, slower training compared to simple models, still produces static embeddings, cannot fully capture context like transformers. FastText versus contextual embeddings. FastText produces static embeddings. Example concept. Same word means same vector always. Example. Bank means same vector for all meanings. Modern models like BERT, GPT produce contextual embeddings. Same word plus different sentence means different vector. Concepts learned from FastText. Understanding FastText helps learners understand. Checkmark how subword modeling improves embeddings. Checkmark how NLP handles rare and unknown words. Checkmark how character level features capture meaning. Checkmark how embedding models evolve from word to vec. Checkmark how morphology impacts language understanding. FastText is an important step between traditional embeddings and modern NLP models. Simple definition. FastText. A word embedding model that represents words using character n-grams. Subwords. Allowing it to handle rare and unseen words effectively. Final summary. FastText is an advanced word embedding technique that improves upon traditional models by representing words using subword information. By breaking words into character n-grams, FastText can understand word structure, handle rare words, and even generate embeddings for unseen words. It is widely used in text classification, multilingual NLP, and applications where word variation is common. Although modern transformer models provide contextual embeddings, FastText remains a powerful and practical tool for many NLP tasks.